Hi, everyone, and welcome. My name is Vadim, and I'm an engineering technologist at Dell Enterprise Technical Marketing. My focus is on Dell PowerEdge servers, specifically Intel. And today I have a demo for you for the latest 17th generation servers that we have. Our agenda is we're going to do the server overview, then talk a little bit about Xeon 6 E-cores versus P-cores, some AI on CPU, PERC 13 overview, about our demo depot program, and we'll finish up with Q&As and our server petting zoo that some of you might have seen in the back. So here it is. Our 17th generation PowerEdge servers offer major performance gains with the next generation Intel Xeon 6 processors, DDR5 RAM, PCI Gen 5, and making them ideal for Red Hat Enterprise Linux and OpenShift workloads. This architecture aligns tightly with Red Hat's certified ecosystem to ensure reliable operation across virtualized, containerized, and bare metal deployments. iDRAC 10 adds a redesigned 64-bit management controller with stronger security and expanded automation capabilities, enabling seamless integration with Red Hat Ansible. Together, the 17G platform and iDRAC 10 deliver a secure, high-performance, automation-ready foundation for enterprise-scale Red Hat environments. And here we'll walk through the server lineup. So this slide shows our 4 rack mount options. I have one of them on display in the petting zoo. And here you can see them side by side, 2 in the performance family and the 2 in the optimized family. And here's the quick rundown. The R670 on the left, that's a 1U dual socket performance server. It supports up to 32 DIMMs, a mix of E3 and 2.5-inch drives. You get PCI Gen 5 and OCP 3.0 connectivity and gives you a lot of bandwidth and expansion flexibility. System is really geared towards high-density virtualization, cloud-native workloads, scale-out databases, and software-defined storage. Because it supports dense GPU configurations, it's a strong choice for compute-heavy environments as well. Then we have the R770, similar to what we have in the petting zoo. It's the larger 2U dual socket counterpart to the 670. It has more room for scalability, up to 22.5-inch drives, and actually about 44 E3.S drives. This is a heavy-duty virtualization and hyper-converged infrastructure system in the lineup, built for big data analytics, large-scale software-defined storage deployments. And if you need most of the CPU density and the most expansion, that's the flagship of the performance side. And we just announced at the NVIDIA GTC this week that the R770 has the support of 4 RTX Pro 4500 GPUs. And on the right side, you can see the optimized server starting with an R470. That's a 1U single socket designed for medium density environments, up to 16 DIMMs, and a healthy mix of E3 drives. Again, same features, PCI Gen 5. And then moving on to the 570, it's a 2U, I'm sorry, yeah, 2U dual socket system and focuses on capacity and flexibility, up to 32 DIMMs, and it has 3.5-inch drive options for high capacity storage. And it also can support GPUs. So some highlights. On the technology side, across all 4 models, you get the same core technology improvements. Intel Xeon 6 processors, faster 64 megatransfers per second DDR5 memory, PCI Gen 5 support, next generation PERC 13 RAID controller, and enhanced cooling efficiency. Memory capacity tops out at 8 terabytes of the performance models and 4 terabytes on the optimized models. So the lineup gives you a strong range from dense compute to capacity optimized virtualization. All right, and here's the quick overview of the key technologies of the platform. First of all, again, we are using the latest Intel Xeon 6 processors, both Sierra Forest and Granite Rapids, up to 144 cores per CPU, includes CXL 2.0 for better memory on device expansion, and all with improved performance per watt. Memory moves up to DDR5, running at 64 megatransfers per second, giving us higher bandwidth and better reliability. And then we're also aligned to an open ecosystem with OCP DCMHS server standard, and that includes modular form factors, OCP 3.0 NIC, and industry standard firmware. And then storage also gets a major update with EDSFF E3.S NVMe Gen 5 drives. Form factor gives us better density, thermals, and packaging with the also especially helpful in space-constrained servers. It also expands the classes of the NVMe offerings. Now on the quick look at the Dell-enabled technologies in these servers. So we've introduced our next generation PERC 13 RAID controllers. It delivers up to 4 times the performance of the previous generation and full support for E3.S NVMe Gen 5 drives. We have BOS N1 and M.2 interposer with EFI secure boot and hot pluggable M.2 options. And also an OCP form factor for deployment flexibility. Also, cooling and efficiency have been improved with cold aisle and hot aisle support, multi-vector cooling 3.0, and high airflow chassis with optional direct liquid cooling. We've expanded accelerator support with GPUs, DPUs, and CXL devices. And on security, we maintain zero trust approach with solder down TPM, silicon-based root of trust, MFA, and end-to-end platform integrity. And now we're going to jump into a little bit of the E cores versus P cores. So this slide shows how the Xeon 6 family is designed to meet different market needs. So towards the top, you have your P core series that's optimized for performance. That's where you need to run compute-intensive or AI workloads. And on the bottom, you have E core that's also optimized for efficiency, but these are great for high density and scale-out environments where the core count and throughput matter more than per core speed. These are different workload mapped to core types. Performance core systems that handle AI, HPC, and heavier data workloads, while efficient core systems are ideal for high density, scale-out, and web-focused services. This helps customers pick the right core for the right job. And here, this is a quick recap that we can see that the main characteristics of P cores are the higher clock speed, hyper-threading, and large cache with high-speed memory. And E cores have lower clock speed, single threading, and lower power consumption. So here's the AI and CPU, and I'm going to have to switch to a separate video for that. Let's see if we can get this going. So here I have a little demo of the this package that we have that to show off AI and CPU. Basically, there's 3 demos in this one. I'm only going to focus on the computer vision one. And there's 3 demo scenarios you can run: CPU with AMX enabled, and GPUs as well. And this kind of runs through all 3 scenarios and shows you the performance differences. So this demo has a couple of pre-canned videos that are you can pick from, and two run modes. One is auto scaling, where it'll actually scale up the load until it can, hit the limit, and then it'll run at that limit to show you the full system capabilities, versus where you can quick how many streams you want to do, and then that's for like if you want to do apples for apples comparison. You will see the all sorts of statistics in the output. Your power consumption, your CPU and memory utilization, and all that kind of things. So once it shows the comparison, you'll see how much the increase is between, how much the AMX helps to process your AI inferencing much faster, and then of course the GPU, the jump is magnitudes more. I want to make sure we kind of pause on that comparison screen here. So right now, as you can see, it was running the GPU accelerated test, and now it's just running the CPU without AMX. Click here. Oh. Trying to pause on that comparison screen. So as you can see here, just the CPU, it was able to process about 290 frames per second, about 4 streams. With the AMX, that number jumps more than double, and the number of streams also doubles. And with the GPU, so this particular server has dual RTX Pro 6000s, and that number of frames per second is significantly higher at 3,544, and able to handle 16 streams. All right, and then we'll go back to this. So here's the kind of quick recap table of the performance. As you can see, AMX gives a strong performance uplift without changing hardware platforms. It's an easy way to boost throughput on modern CPUs by nearly 3 times, and GPU acceleration takes performance even further, delivering more than order of magnitude improvements over the baseline and dramatically increasing scalability. And this basically shows a clear progression of performance capabilities, starting with the standard CPU execution, stepping up significantly with AMX, and reaching maximum throughput with full GPU offload. And now we're going to jump into the PERC 13. So with introduction of PERC 13, we have strongly improved overall I/O performance, and new COL engine. Cache size is reduced to 192 megabytes, but it's optimized since low media no longer require large provisioning. We have more PHYs added, and now with 32 device-facing links with PCIe Gen 5 supported on both host and endpoint. It has SuperCap and a MCU, which is the small embedded controller that manages power loss protection, so kind of like the old battery management system, BMS. Let's see, and this shares the same OS drivers management and API and CLI as PERC 12 for easy continuity. And here's some the quick rundown on the PERC 13. The picture is simple. It's a huge jump from an older PERC controllers. Everything gets faster. Reads, writes, and latency and rebuilds. So as you can see on the reads bandwidth, it jumps from about 14 to 54 gigabytes per second, and writes climb to about 5 to 54. And also a huge jump in the IOPS, also a huge rebuild improvement from 90 minutes per terabyte down to about 22. All right, and last but not least, we have our newly revamped Dell Demo Depot program. It's an easy way to try out our new Dell PowerEdge servers with Xeon 6 processors in your own environment for free. So you can get the systems delivered fast to you, and the terms are up to 90 days, and you can test in your own environment at your own terms. We ship as soon as the next day, and you get a free on-site engineer if you need, which is myself. And yeah, I'm based here locally, actually. And there's a QR code, and I have a bunch of handouts.